Hey everyone, and welcome to This Explainer. Look, we all know money laundering is a multi-trillion-dollar global problem. It's massive. And yet, legacy anti-money laundering systems are just notorious for absolutely drowning analysts in false alarms. We're talking about a staggering 95% false positive rate in some cases. So today, we are unpacking a really fascinating framework that's actively reshaping how financial institutions tackle this whole mess. We're going to be looking at ARIA, an agentic risk intelligence platform created by Princeton Strategy Group. We'll explore exactly how ARIA uses a highly specialized multi-agent AI architecture to fundamentally change the game for modern AML.
Okay, let's dive right into this by defining our core concept. When we say a multi-agent framework in the context of AR, we're talking about a system designed to orchestrate modern AI/ML intelligence. But it doesn't do this through one giant monolithic algorithm. Instead, it delegates very specific analytical tasks to specialized digital agents. Think of it like moving from using a single basic calculator to managing a fully synchronized team of expert analysts who are all communicating with each other in real time.
So here's our quick roadmap for today. We're going to cover the multi-agent architecture, dynamic segmentation, interactive threshold tuning, the SAR Priority Worklist, and finally wrap up with the unified investigation workflow.
All right, kicking things off with Section 1, the multi-agent architecture, or as I like to think of it, the brain and the detectives. Now, what's really interesting here is how this structure totally transforms the workload. Let's take a quick anatomy tour of the system. Imagine this architecture as a highly efficient digital detective agency. Right at the top, you have the orchestrator acting as the central chief. When an analyst types in a plain English query, the orchestrator instantly routes that request to the exact right specialist. That might be the threshold agent for managing risk indicators, the segmentation agent for building behavioral profiles, or the policy agent, which is quietly ensuring that security and compliance rules are strictly enforced in the background.
Moving right along to Section 2, dynamic segmentation and profiling. This is all about grouping behaviors.
This is where the segmentation agent really goes to work. And the best part? Analysts don't need to write complex SQL code anymore. They engage directly with the data using intuitive, plain English prompts. By just asking to see behavioral segments for individual customers, the system instantly generates dynamic tool result charts. It produces these high-level behavioral segment summaries on the fly. For instance, you could instantly isolate a specific cluster of high net worth individuals based on things like income, account age, and balance, identifying it clearly as a stable, low-risk group. It makes complex data interrogation incredibly fast and, honestly, super accessible.
But what is actually happening under the hood? Well, the segmentation agent is deploying what's known as k-means clustering. It's taking these vast amounts of data across various demographic and transaction behavior features, and it's grouping customers into dynamic risk profiles. Businesses are automatically sorted into segments like mid-frequency, low-value versus high-frequency, high-value. And because this is fully dynamic, these aren't just static risk rules written by someone 3 years ago. They are highly accurate reflections of current, actual day-to-day behavior.
Which brings us to Section 3, interactive threshold tuning, or as we can call it, calibrating the radar. And this brilliantly illustrates how the system fine-tunes its sensitivity. To properly calibrate the radar, the threshold agent maps out the trade-offs between catching suspicious activity, the SAR catch rate, and generating a false positive. It utilizes these really slick interactive 2D sweeps to generate adaptive parameter recommendations for very specific alert scenarios. So, instead of just guessing where to set a dollar amount trigger, analysts can immediately grasp exactly how tweaking a parameter will impact their true positive detections versus their false positive rate. No more guesswork.
Next up, Section 4, SAR Priority Worklist. This is all about focusing human effort where it really matters.
Because, all this agentic analysis, the clustering, the threshold sweeps, it has to ultimately translate into actionable intelligence. The SAR Priority Worklist takes all those alerts and actually ranks them. By adjusting a simple minimum SAR score threshold slider, analysts surface what are called out-of-fold predictions. Essentially, the AI is testing its accuracy against data it hasn't even seen before, but it's rigorously trained on the institution's own labeled historical data. You are basically asking the AI, hey, based on everything we've flagged as real money laundering in the past, which of today's alerts look the most identical to those confirmed cases?
The model boasts an incredible ROC-AUC score of 0.943. Now, in predictive modeling, a score that close to 1.0 means the system has a phenomenal, almost flawless ability to distinguish between the actual money laundering signals and the harmless background noise. It completely grounds the system's effectiveness in hard, undeniable data.
Finally, Section 5, the Unified Investigation Workflow.
we are zooming in on the analyst desk.
So the AI has done all the heavy lifting of sorting and scoring. Now the human investigator takes the reins. To make this as seamless as possible, ARIA structures the workflow into 3 very clear steps. First, the analyst reviews a completely consolidated case history. Second, they run a check against the nightly refreshed OFAC screen, making sure we catch anyone sanctioned by the Office of Foreign Assets Control. And third, they can instantly generate automated draft narratives for the suspicious activity report itself.
Let's see how this actually builds together for the user. The Unified Investigation Panel consolidates all of those tools into one expert view. Customer income, risk flags, lifetime alert activity, it's all instantly accessible in a single location. There are quick action buttons that allow the analyst to immediately generate that draft SAR narrative or run the OFAC screen without ever having to switch applications or dig through external databases. It's a massive time saver.
And to truly visualize the threat, analysts deploy these interactive transaction network graphs to map counterparty connections. It's basically a dynamic map of financial behavior. By charting edge thickness to represent the volume of money and using arrows for the flow direction, the system instantly exposes complex flow-through techniques and hidden money mule patterns that would normally take days, if not weeks, to piece together on a spreadsheet. It literally makes the invisible visible.
So we've seen how the orchestrator, the specialized agents, and the unified workflow all come together to totally strip away the busywork of traditional AML. It leaves us with a truly fascinating landscape to consider. As multi-agent frameworks like ARIA handle the heavy lifting of dynamic threshold tuning and complex behavioral segmentation, how will the human analyst's role evolve to focus purely on high-level threat strategy? When you no longer have to spend your entire day finding the needle in the haystack, what can you achieve once the AI simply hands you the needle? It's a powerful question for the future of financial compliance. Thanks so much for joining me for this explainer.